Hello, college algebra student. This video is for chapter 2.3, part 3. And in this video, we are concentrating on solving literal equation. What is a literal equation? Literal equation is like a formula that has multiple variables, um, like the one that we went over, such as P times 1 plus RT equal to A, right? So this is an equation that involves three variable P and R and T and also A. Also parameter is equal to 2W plus 2L for um, rectangle is also a literal equation that has multiple variable, not just one variable on one side, one variable on the others. So solve literal equation means I have one unknown on this side. Now I want to solve for the other unknown so that I have another equation. So what are the steps involved? So I summarize it into 4 steps. So the first is to simplify both sides of the equation. So this would be simplify. It's a typo. Simplify both sides of the equation by clearing grouping symbols and fractions. So if there's any grouping symbol and fraction, you want to, combine them, simplify them, particularly grouping symbols and particular fractions. We want to clear grouping symbols if the variable that you want to solve for is in the grouping symbols, or if your unknown is in a fraction. Okay, so the second step is to isolate all the variable terms. Anything that relates to what you want to solve for, you want to move all of them on one side and the other terms on the other side. Just like when you solve an equation. Step 3 is to factor the unknown variable if there are more than one variable terms. Step 4 is use multiply and divide probably to solve for the unknown. So it's very similar to solving linear equation. So let's do an example. Okay, so this is of course a literal equation. I have C equal to 5 over 9 F minus 32. So I have this unknown relating each other, but I want to solve for F. That means when I say I want to solve for F, that means I want an unknown of F equal. So circle what F is. Well, F is inside a grouping symbol, so I have to break this grouping symbol. Now, most of the time, we say we want to break the grouping symbol, we distribute, right? But not in this case because there's nothing outside. So the easiest ways to break this grouping symbol is to get rid of the 5 over 9 by multiplying a reciprocal or divided by 5 over 9. So what you can do is multiply by 9 over 5 on both sides, right? 9 over 5. So that would mean 9 over 5C equal to just F minus 32 because your multiples here in the parenthesis is gone. It's 1. And if it's 1, then I don't need to write the grouping symbol. So now what would F be then? F would be, I only have one F on this side. So I would just leave F on this side and then get rid of everything that has no F to the other side. So plus 32 plus 32. So the answer would be 9 over 5C plus 32 is equal to F. And this is my new formula or the equation for F. Solve for F. I have F equal, and that's the answer. Okay, so on the other side, you cannot have F. Second example is the formula is x minus 9 equal to 4x plus 2y, and we want to solve for x. So that means I want x equal something. Okay, so you would say, well, Miss Chen, it's very easy. You plus 9 and that's done. No, that's not correct. Why? Because x is here as well as here. If you want to solve for x equal, you cannot have x on the other side. Okay, x has to be not showing up. So if I see this, I would say, well, this is an x term, this is an x term. Whenever it has that unknown variable, it's called an unknown term. So this has to be with this x on this side. So I would do minus 4x. Minus 4x. Now because x is all the x term is on the left hand side, I need to get rid of all the non-x term so that it's on the right hand side. So I have on the left hand side x minus 4x because negative 9, so this cancel. And here I have, this is all gone because minus 4x means it's gone. 2y plus 9, right? So 9 will show up here when I add them. And this would goes away. So all the x on one side, x term minus 4x term is negative 3x. Can I combine like term? I can. 2y plus 9. So now I combine like term. I have negative 3x equal to 2y plus 9. How do I solve for x equal? I divide it by negative 3. X would equal to 2y plus 9 all over negative 3. When you divide, you have to divide every single term, so we just do it this way. Okay, so this is the answer. So you can see that this is better than you just plus 9 and then solve for x. Because here, I do not have any x on this side. Whereas if you just say add 9 and like do it like this, you still have an x, and that is not solving for it. Example 3. So S is equal to L minus RL. Solve for R. Solve for R. So you look around. Oh, I see R here. So this is called the R term. So I only have one R term, so that's good. I just leave it on this side. And I need to get rid of the L. So minus L, minus L. So the left-hand side will be S minus L. The right-hand side, do I have just RL? No. Then you have to keep this. This minus RL belongs to this term. Negative RL. Okay, remember, the subtraction become a negative 1 kind of attached to RL. So this is one term with two variables, but I want to solve for R, so I just need to divide by L. So this would be, well, actually I should divide by negative L, right? Because this is a negative RL, so if I divide negative L, I would have R equal. And this side will be S minus L over negative L. Can I cancel this? No, you cannot. You can simplify it by splitting it, but you cannot. So what we can say is R is equal to S minus L over negative L. So that's good enough. Or if you want to, you can times negative 1. You don't like to have this negative L over here. So you can multiply negative 1 top and bottom. So this become L minus S. Because if you multiply negative 1, this L become positive and this become positive. Again, you should not cancel because this is terms and this is a term, but this has two terms, so you cannot cancel. So this is the answer. Example 4 is a little bit more tricky. It say the given formula is x is equal to a plus b plus c over a times b. We want to solve for a, so a equal. Now the difficult part is I see a here and I see a in the bottom. So it seems like I have two a's showing up in two places. So what is the best way to group them? Should I just leave them over here? Then don't change them, but how do I get rid of this B and C? Because terms I have to get rid, right? To get rid of terms. Plus and minus are terms. So the way to do this is I have to free this out, right? So freeing this out, I have to get rid of A, B. So to do this, I would multiply A, B on both sides. A, B. The goal is to free this numerator out. So the left-hand side now have A, B, X. Still one term because it's product. And then this would be, if I cancel this, it will be A plus B plus C. Now, this is an A term. This is an A term because we don't care what products it has, but it's so long as it's an A, it's an A term. This is not an A term, so I would minus A so that all the A terms is on one side. So you see how A, B, X minus A is equal to B plus C now. There's no a here. These are a term because they all have some kind of a in their term. Now I have two terms, so I can't divide bx or something. I have to factor first. Factor bx minus 1. When I factor, because both of them has a, so at least a is the common factor. Equal to b plus c. Now a times this equal to b plus c, so a equal to what? I would divide by this bx minus 1 divided by bx minus 1. So a is equal to b plus c divided by bx minus 1, and I'm done. So a is equal to b plus c divided by bx minus 1. So that's the answer for that one. And notice that there is no a on the right-hand side. Example 5, x over a plus 1 over b equal to y. Solve for a. Well, I see a here. That's really good. I don't see any other a, so the better way is get rid of this, right? So we will get rid of 1 over b minus 1 over b. Here I would do minus 1 over b. So x over a equal to y minus 1 over b. Now, but this a is in the denominator, so it is hard to process. So the best way to do this is to flip it over so the a is in the top, right? So let's do a flip over. There's other way to do this. Okay, maybe I'll, try to give you another alternative. But I like to do it this way because a over x, you reciprocal, it would be reciprocal of this. Y minus 1 over b. Okay, do not just reciprocal individually. You have to reciprocal the whole thing. Now, how do I get rid of the x then? You multiply by x on both sides, right? Multiply on x on both sides. So now I have a equal x over y minus 1 over b. So this is the answer, but this is a complex fraction. So how do I get rid of this 1 over b here? I multiply b over b, top and bottom. So I would have xb over what? B times y, yb minus 1. You see how b times x and b times 1 over b is 1. This is yb, x like that. So this is the answer. A is equal to xb over yb minus 1. So this is the first method to solve this. Another method to solve this is use common denominator. So second method. So very often there is more than one way to solve it, but you would get the same answer. So you would say, well, I have x over a plus 1 over b. Why don't I do the common denominator? So I have xb over ab plus a over ab, because I'm going to multiply this by a and multiply this by b, right? It's equal to y. And then I would have add them, or I would multiply both sides by ab. So I have xb plus a equal to yab. Because after I do that, I multiply ab to clear fraction. You see one of the steps is clear fraction. So now I have look at, oh, this is an a term and this is an a term. So put them on the one side. So yab minus a. So xb is equal to this, but both of them has a. I factor it out. Yb minus 1. And then I divide them. So a would equal to xb over yb minus 1. You can see that it's the same as what we have earlier. So you can use either method. The goal is to have the other side all without a. Okay. So that is the end of 2.3.